So where we left off yesterday was we started to investigate some similar right triangles. And the first investigation that we did was we drew some triangles that were similar to one another. We knew that they were similar for a couple of reasons. Number one, we took a ratio of their side lengths of the height to the base for all three of them, and we saw that that ratio was the same. When we compared height to base, height to base, height to base, we got this ratio of 0.6. Okay? And then the second thing that we did was we measured using a protractor this angle at the bottom, and we got around 30, 31-ish degrees. Okay? So, and also the other thing that we recognized was that when we have a triangle, all of the angles add up to 180. So if this angle at the bottom is 30, and this angle over here is 90, then the angle at the top has to be whatever else makes up 180, right? So 30 plus 90 makes 120. And then what else do we need to get up to 180? We need another 60 degrees. So this one has to be 60, and that's true for all three of them. And what that means, the fact that all the angles are the same, the fact that the height to base ratio is the same, is that these triangles are similar. Okay? Once we established that, well, it wasn't so surprising that the angles were equal and that the ratios were equal. Okay? And then we did the same thing over here where we had a drawing of these sort of embedded triangles, and we established that the top angles had to be the same because they all have a right angle and they all share this angle at the bottom. And so these top angles have to be whatever's left over from 180 once I take out the 90 degrees and this angle A, which means that they're all the same. And then when we started looking at the ratios over here of, firstly, we looked at the length of each hypotenuse and the length of the side opposite to angle A, which is the one across from it, to either the hypotenuse, which for ABC would be 5, or the adjacent side. Adjacent means next to or beside to the hypotenuse. Okay? And these notes are not as filled in as yours will be, because this is where I got to in my afternoon class. But all of these ratios were also equal. And what were the values of those ratios? When we looked at opposite side to hypotenuse, what was the value of all of these ratios for all of the similar triangles? What did we get? Yep, 0.6, yeah. And what about when we looked at the ratio of the adjacent side to the hypotenuse? 4/5, yeah, it's 0.8. Right, so when we take the fractions and we turn it into a decimal, they're all 0.8. So what we saw, again, was ratios of the corresponding sides are equal. All of the angles are equal. Again, this is not surprising. Okay? And so where we ended up at the end of class was I started to talk about the fact that, and I'm going to do this at the bottom, that a long, long time ago, mathematicians decided that it might be useful for people to have this bank of information where you might have a right triangle where, let's say this base angle over here is 1 degree. Okay? And when we have this angle over here of 1 degree, this is 90 degrees. Okay? We can label the sides of this triangle relative to this angle at the bottom. This should go into your notes on the following page at the bottom. Okay? Sorry, I don't think you guys saw that, but I did scroll to the next page. I did that quite quickly. This is sort of where trig comes from. Okay? And what we can do is we can label the sides of this triangle relative to this angle at the bottom. And here's the way that we talk about them. Firstly, the hypotenuse is the hypotenuse. So in this case, the hypotenuse is this side length right over here, right? It's the one that's across from the right angle. So this is the hypotenuse. And then the other two side lengths we call the opposite side and the adjacent side. The opposite side is the one that's across from or opposite from the angle that we're looking at. So for this angle of 1 degree, the opposite side would be this one over here on the side. The adjacent side is the one that's next to the angle that's not the hypotenuse. So if you look at this angle of 1 degree, there's kind of two sides that's next to the angle. There's this one that's at the bottom, and then there's this slanted one. One of those two sides will always be the hypotenuse. It's the one that's not the hypotenuse. So this one is the adjacent side. And again, adjacent means next to or beside. Yep. Yep. Okay. Now, one thing that's really important to know is that opposite and adjacent.
Mr. Waters, please come into the main office. Thank you.
Okay. One thing that's really important to know is that opposite and adjacent sides depend on which angle that you're looking at. The hypotenuse is always the hypotenuse because it's the longest side. But let's suppose instead I was looking at this angle at the top instead. Which side is opposite to the angle at the top? The one at the bottom, yes. And which side is beside or adjacent to the angle at the top? The one on the side, yeah. So what I'm going to do is I'm going to sort of redraw this. And let's say instead, same triangle. This is 1 degree, that's 90 degrees. If you add those together, you get 91 degrees, okay? If they all have to add up to 180, well, what would this one be? What's left over up here? 89. So this would be 89 degrees, okay? If I'm labeling this triangle using this angle instead, this is still the hypotenuse, because that never changes. But now, the side at the bottom is the opposite side, because that's the one that's opposite to the 89 degree angle. And this one is the adjacent side. Okay, so hypotenuse is always hypotenuse. The opposite and adjacent depend on which angle you are looking at in the triangle. Okay, now back to where trig comes from. Mathematicians a long, long time ago thought, you know what? So much of our world uses right angles. It might be really useful to store the information around the ratios of side lengths in every right triangle in a book somewhere. So what we might do rather is we might look at this triangle and we might draw it, right? Let's say we draw a triangle where we have the exact triangle, and obviously this one is not drawn proportionally, right? Because this angle at the top is not 89 degrees. Or it's not drawn accurately, I should say. But what they did was they measured all the side lengths, and then they recorded the ratios of the side lengths in a book. And then they gave that book out to people, and people could use that book and reference it to solve problems. And up until quite recently, I would say probably somewhere around the 80s, that's what people had to use when they tried to use trig ratios. They would have to go and look it up in a book. And I showed you a picture of what that looks like yesterday. It's called a logbook, okay? And it had all of the trig ratios in it, and it also had some logarithms in it, which is something that you might look at later on in your math careers. Today, all of those values are stored in your calculators on those 3 buttons that we talked about, the sine button, the cosine button, and the tangent button. So you don't have to carry around a book anymore and actually go to the page in the book where you want to look up, well, what is the ratio, for example, of opposite and adjacent for a triangle where this angle at the bottom is 1 degree? You don't have to go to the page number and look that up. You can just access that information in 2 seconds on your calculator. Okay? Let's talk now, though, about how we can pair up sides. We've got 3 sides on this triangle. How many different ways can we pair them up? Let's say we wanted to pair up the hypotenuse with something. How many different ways could we pair up the hypotenuse? What could we pair it up with? You got 3 sides. You want to pair up one of them is the hypotenuse. What could you pair it up with? It's almost like you have like 3 friends, and one of your friends is the hypotenuse, and then you've got 2 other friends. What are the 2 other friends that are available to pair it up with? One of your friends is the hypotenuse, the other one is the opposite, and the other one is the adjacent. You've decided one of the people in your 2-person group is going to be the hypotenuse. Okay, let's get 3 people up here. I need 3 volunteers who are going to be my 3 people. Come on. Thank you. Come on up. Who's another person? Thank you. Come on up. And one other. Really? Okay, fine. I'll be the 3rd person. Okay, so the 3 of us, I'll tell you what, I think you're taller than me, right? Okay, you can be the hypotenuse because you're the tallest. Hypotenuse has to be the longest. And you can be opposite and I'll be adjacent. Is that okay? Okay, so Luke is going to be the hypotenuse. We're going to pair the 3 of us up and see how many different ways that we can do it. Luke's the hypotenuse, and I want to make a pair, and Luke has to be in the pair. Who else could go into the pair with Luke? If Luke has to be in the pair, how many different groups could I make with Luke in them? 2, yeah. Who else could pair up with Luke? Who could pair up with him? Leo. Okay, so you could have Leo and Luke. And sorry, you were the opposite? Okay, so you could pair up opposite and hypotenuse. Or who else could pair up with Luke? Me. Adjacent and hypotenuse. Yeah? Okay. Are those the only 2 groups that you could make with the 3 of us? No, what's the other group that you could make? Yeah? Me and Leo. Yeah, so take Luke out of the equation. Me and Leo could pair up. And that's opposite. She's opposite. I'm adjacent. So you could also pair up opposite and adjacent. Does that make sense? So you got 3 sides and you want to pair them up. There's 3 ways you can do it. Thank you very much. You guys can sit down. Thank you. Applause, yes. Okay. So if we want to pair up sides in a right triangle, and there's 3 sides, there's 3 different ways we can pair them up. We can pair up these 2 sides, these 2 sides, or these 2 sides. And those 3 pairs make the 3 trig ratios. Okay? The first pair, which involves the opposite side and the hypotenuse, is called the sine ratio. And the sine ratio is defined this way. The sine of an angle is the ratio of the length of the opposite side in the triangle to the length of the hypotenuse. Okay? So the sine of an angle. Now in mathematics, we typically use a specific symbol when we're talking about an angle. And it's not a symbol that you may have seen before because it's a Greek letter. Has anyone seen it before? Maybe some of you have. Do you know what it's called? It looks like this. How many people have seen that? Some of you? Do you know what it's called? No, it's called theta. Okay. Equals the length of the opposite side over the length of the hypotenuse. Okay. Now the second way that we paired things up was the adjacent and the hypotenuse. And that's called the cosine ratio. The cosine of a particular angle is the ratio of the adjacent side to the hypotenuse. And then the third way was, let's take the hypotenuse out of the equation. That's when we got Luke out of there, and Leo and I paired up, and that was the tangent ratio. And that is the ratio of the opposite side to the adjacent side. Okay. So what I want to do now, and we're going to come back to this triangle of 1 degree in a second, is I want to remind you guys of this little investigation here. Let's actually even look at this little triangle that had a length of, a height of 3 and a base of 5, and this angle was about 30 degrees. Yes? Do you remember that one? And we actually measured that angle. Yeah? Ring a bell? Yes? You guys all remember that from yesterday? Okay. So what I'd like to do is just redraw that over here. We're going to draw that over here. So what it had was a height of 3, a base of 5, and we measured this to be 30 degrees. Now, in reality, and I'm going to tell you this right now, we were off by 1 degree. This actually should be 31 degrees. But that's pretty close. Okay? Now, in this triangle, let's label the side lengths of this triangle relative to this 31 degree angle. Okay? Where's the hypotenuse? It's up here. Yep. Okay. Which side is the opposite side? Yep. The 3. Right there. Ah, not that. Opposite. And which side is the adjacent side? The 5, because it's next to the angle but not the hypotenuse. Okay, so what we compared was we compared height to base. 3 over 5. Yes? Okay. Using this new labeling system, the sides that we were comparing were opposite over adjacent. Yes? Okay. Which of the 3 trig ratios is opposite over adjacent? Tangent. Yes. The tangent ratio is opposite over adjacent. What I'd like you to do right now, and what you got when you went 3 over 5, what was the decimal? What was the decimal when we went 3 over 5? What was it? 0.6. Does everybody know that? Some of you are looking at me with blank faces. Go back 2 pages in your notes and look up that ratio. You should all know that that was 3 over 5 is 0.6. The ones with blank faces are still just staring at me with blank faces. Go back and look it up. It's right here, that 3 over 5. Whoops, I went too far. Right? When we went height to base, we got 0.6. Okay? Pull out your calculators. Find your tan button. Mine's right here. And I want you to enter in tan of 31 degrees. And close the bracket if you end up with, if you don't have brackets, that's fine. If you have brackets, close the bracket. And hit enter. Oh wait, I never checked that I was in, I'm not in the right mode. I'm in radians. Okay, let's go back. There we go. Tan of 31 degrees, I'm gonna hit enter. What do you see? 0.6. Okay, so that triangle that we drew yesterday, that exact triangle, a copy of that triangle is stored in the memory of your calculator. So if you know you have a triangle that has a 31-degree angle at the bottom, and you want to know what is the ratio of side lengths between the opposite and adjacent, you can go look it up. Okay? So if you know the angle, you can figure out what's the ratio of the two side lengths by accessing that information on your calculator. How did that information get there? Probably the same way that we did it, maybe using slightly more accurate measuring tools, technology, that sort of stuff, because what we did was pretty primitive in terms of just using pencils and rulers and protractors. But that's the idea. Okay? Now the other thing, let's suppose that you know that the ratio of the side lengths is 0.6 and you want to know the angle. You can figure that out as well. Remember I talked about that the tan to the -1? It's called the inverse button. That's how you access the angle information if you know the ratio. So let's say we knew the 0.6 part, but we wanted to figure out what the angle was. So what I want you guys to do now is to take out your calculators again, and you probably have to hit the second button or the shift button. So hit that first, and then hit the tan button again. And you're gonna get the tan inverse button. And what you're gonna do now is enter in the 0.6, or you could even enter in 3/5, the actual ratio of the side lengths. I'll do it both ways. 0.6, and I'll close the bracket again, and I'm gonna hit enter. And what do you see? 30.9, which rounds to the nearest degree, 31 degrees. So this whole triangle is stored in the memory of your calculator. If you know the angle, you can find the ratio of the sides. If you know the ratio of the sides, you can find the angle. And that's true for every single triangle possible. Okay? Now, by the way, you don't have to enter it in as a decimal. We knew that it was 3:5 ratio. You could also go like this, inverse, tan inverse, 3 divided by 5, and enter in the actual ratio itself. You're going to get the same thing. Okay? So when I went to this little 1-degree triangle, what I was getting at is that this is where trig comes from, right? We talked about a triangle with a 31 degrees and how that's stored in the memory of your calculator. But this one is as well, as is this one, where this is now 2 degrees at the bottom. And all of the side lengths are stored, as are the ratios. And as is this one, where now this angle at the bottom is now 3 degrees. And so on and so forth. And not only the 3 degrees and 2 degrees, but all of the decimals in between. So 2.1, 2.2, 2.13, every possible angle that could be at the bottom there. All of these triangles are stored in the memory of your calculator in terms of the ratios of their side lengths. And so what we're going to learn to do today is how do we use this storage of information to solve problems? Okay, flip over the page. Actually, I just talked about this a little bit already. Okay, so how do we use these ratios? Well, we can use them to calculate a side or an angle, a non-right angle, like one of the smaller ones of a right triangle. And the idea is this. Basically, each of these trig ratios are an equation. You've got sine theta equals opposite over hypotenuse. You've got cosine theta equals adjacent over hypotenuse. And you've got tangent theta equals opposite over adjacent. And when I was in school, there was a mnemonic that we used to remember the trig ratios. They're on your formula sheet now. By the way, when I was in high school, we didn't get formula sheets. Isn't that cruel? I think it's pretty cruel. It's so toa, so that you can see sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. And the idea between these three ratios is that each one of them has three unknowns in them. One angle and two sides. One angle, two sides. One angle, two sides. And in any equation, as long as you know all but one unknown, so in this case, 2 out of 3, you can solve it. So if we wanted to find a side length, let's say we wanted to find this, for example, we would have to know the angle in the other side length. Or if we wanted to find this side length, we'd have to know the angle in the other side length. Or if we wanted to find this side length, we'd need to know the angle in the other side length. If we wanted to know an angle, one of these guys, we'd have to know both side lengths. Okay, so each one of these is an equation. If we know 2 out of 3, we can solve that equation for the third one. Okay, now we already talked a little bit about the calculator. How do you use it? If you know the angle, right? If you know the angle, you just go like tan of 31 degrees, for example, equals, and you're going to get the ratio, 0.6. Okay, so this over here is the ratio. That's how you would get a ratio. If you know the ratio, so I should say if you know the angle, and I'll put, and want, if you know the angle rather, and want the ratio. Okay? Here, if you know the ratio and you want the angle, if you want to go in the other way, and want the angle, you would go tan inverse of 0.6 to get 31 degrees, right? And this is your angle. Okay. Let's actually do some examples now, because this all seems very theoretical. We've got to put it into practice. Okay. Example 1. These ones both actually have to do with calculating an angle. So we'll start with that, and then we'll do example 2 where we're calculating a side. Okay. Now, whether you're calculating a side or an angle, the process is the same. Yeah. Okay. The first, so I'm going to write the steps over here. And this first step, I know I harped on it when we were talking about Pythagoras. Some of you guys can get away with this, without doing this, I should say, when you're using the Pythagorean theorem. Do not try and get away with this when you're using the trig ratios. It's crucial. Label sides relative to the angle you're using. Right? And when I say label sides, I mean label them with opposite, adjacent, and hypotenuse. Okay, so we're going to start with this one. Now we want to figure out what angle A is. If we want to figure out angle A, that's the angle that we should use to label the sides. Here's angle A. This is what we're going to use to label the sides. Okay? I'm going to start with the hypotenuse. I always start with the hypotenuse because I want to make sure to get that one right. Which of the sides here is the hypotenuse? Which of these 3 sides is the hypotenuse? 6.9. Yep. Okay. Which side is the opposite side? Yeah, so opposite, what I can suggest you do is go to the angle, go across. That's the opposite side. And then the one beside it is the adjacent side. Okay? The first step. Step 2, you need to choose a trig ratio. And when you're choosing a trig ratio, you need to think about the fact that you need to know 2 out of 3. Oh, yes, absolutely. Good idea. That's a great idea. Okay? So you need to choose a trig ratio. You must know 2 out of 3 unknowns. Okay? So let's talk about that for a sec. We want angle A. So we want an angle here. Each of the trig ratios has 3 unknowns, an angle and 2 sides. Our unknown here is going to be the angle. So what do we need to know in this case? If we need to figure out the angle, what are we going to need to know out of those 3 unknowns? Each equation has 3 unknowns, 1 angle, 2 sides. What we don't know is the angle. What do we need to know to be able to solve? The 2 sides, yeah. We need to know the 2 sides, exactly. Okay, which 2 sides do we know? What are the 2 sides called that we know? Opposite and hypotenuse, yeah. Which trig ratio uses opposite and hypotenuse? Yeah, sine, yes. Sine uses opposite and hypotenuse. So that's the trig ratio that we need to use so that we know 2 out of 3. Does that make sense? No? Yes? I need some response. If you think, well, maybe what I'll do is I'll write out SOHCAHTOA here, right? So that we have that. Okay. If we want an angle, we've got to know the two sides. The only two sides that we know are opposite and hypotenuse. The trig ratio that uses that is the sine ratio. If we tried to use the cosine ratio, we have too many unknowns because we don't know the adjacent side, plus we don't know the angle. And the same would go for the tangent ratio. So we've got to use sine here. Okay? So what we're going to do next is we're going to write the sine ratio out without filling in any information first. I'm going to write out sine theta equals opposite over adjacent. Now, hypotenuse. There we go. Okay? So I've chosen my trig ratio. The third thing I'm going to do is fill in what you know. Okay? Do I know the angle? Do I know the angle? No. What is the angle called in this triangle? What's it called? Up here. What's it labeled as? Yeah. A. I don't know it, so I'm going to call it sine A. So fill in what you know. Well, that's what I don't know, so I can't really fill it in. But what I will fill it in with is whatever it's labeled as in the diagram. Equals. Do I know the opposite side? No. Yes. What is the opposite side? 4.3. Do I know the hypotenuse? Yes. 6.9. There we go. Okay. Now, if I know the ratio and I want to get an angle, which of the buttons do I need to use on my calculator? Sine or sine inverse? Sine inverse. So to get the angle, to get A, I'm going to go sine inverse of the ratio. 4.3 divided by 6.9. That's it. Take out your calculators and go sine inverse of 4.3 divided by 6.9. And you get 38.5 degrees. Okay? In this triangle, we're going to start, and so step 4, by the way, is solve for the unknown. And again, step 4 is going to look a little bit different depending on whether you're looking for a side or an angle. Okay. Second triangle. We're looking for angle A, so we're going to label our side lengths relative to angle A. Which side is the hypotenuse? Yes. 6 or 5? I can't even read that. 6. The good news is that once we go online, the screen will be very clear because my smartboard is not the best. It's not that easy to see. It's a bit fuzzy. Okay, which side is the opposite side? Here's the angle. Let's go across from the angle. 5.2. Which side is the adjacent side? Okay. Which sides do we know here? All of them. So if we're looking for the angle A, what are our options in terms of trig ratios? Which ones could we use? Yeah, all of them, because we need the angle. We have the opposite side and the hypotenuse. We have the adjacent side and the hypotenuse, and we have the opposite side and the adjacent. So the more information you know about a triangle, the more options you have. So here you could use any of the three trig ratios. So let's just pick one. We haven't actually done anything with cosine yet, so let's use the cosine ratio, just for fun. Okay, so I'm going to use cosine. And that's adjacent over hypotenuse. And I'm going to fill in what I know. Do I know the angle? That's theta. Do I know what the angle is? I do? What's the angle? No. So I'm just going to write the cosine of A. Do I know the adjacent side? Yes, it's 8.1. Do I know the hypotenuse? Yep, it is 9.6. Okay, so I have the ratio. I want to get the angle. How do I access that information? How do I access that information from my bank of information in my calculator? Cos inverse. Yeah. If you have the ratio and you want the angle, you use the cosine inverse button. So the angle is going to be the cosine inverse of 8.1 divided by 9.6. And that is, I don't know, 32.4. Inverse cosine 8.1 divided by 9.6. And we got 32.5, I would say, because this is a 6, so if we're rounding to the nearest tenth, 32.5. Okay? Okay, so let's talk now about how to find sides. Okay, now the steps are the same. So we're going to start out with labeling sides with the angle that we're going to use. Which angle in this picture over here do you think that we should use to label the sides? We want to find this over here. We want to find that. Which angle do you think we should use to label the sides with? A, yeah, because we know that one, right? We're going to need to know an angle if we want to find a side, because otherwise we're going to have too many unknowns. So we're going to use this angle over here. Okay, so let's do that. This is side A. Okay. What is the hypotenuse in this picture? On the bottom. Okay. What is the opposite side? A, yeah, so I'll use like a capital O. You can see that that's a little confusing. And what's the adjacent? The 6.5. I'll use a capital A. It's called side A, but it's not the adjacent side, right? It's a lowercase a. Okay, now let's think about this. We want side A, which is the opposite side. If you want the opposite side, if that's what you need to figure out, one hint is that when you're looking at your trig ratios, maybe I'll just rewrite this up here so that I don't have to keep flipping back. Is that only, only 2 of the trig ratios includes the opposite. Which one doesn't include the opposite? Sine, cosine, or tangent? Yeah, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if I want to figure out the opposite side, cosine is going to be useless to me because it doesn't involve the opposite side. So I'm going to cross that out. I can't use cosine. I have this angle. I want the opposite side. What is the side that I know? Yeah. Which one? What's the side that I know? Which of the three sides do I know? The adjacent side. So I know an angle, I want the opposite, and I've got the adjacent. Which trig ratio am I going to have to use? Tangent, yes. Because if I tried to use sine, I would have too many unknowns. I would know the angle, but I would be missing two sides. And I can only be missing one side. So I've got to use tangent. Because for tangent, I've got my angle and I've got my adjacent. That's 2 out of 3. Okay, so tangent theta equals opposite over adjacent. Okay, now I'm going to fill in what I know. Do I know the angle? Yeah, what's the angle in this case? 38 degrees. So tangent of 38 degrees equals. Do I know the opposite side? Do I know what the opposite side is? No, that's A. That's the one I'm looking for. Do I know the adjacent side? Yeah, it's 6.5. Okay, so I'm filling out 2 out of 3. And if you choose a trig ratio where you can only fill out 1 out of 3, all you need to do is say, okay, wait a second, this one's not going to work. I need to choose another one. Just go back to the drawing board and choose a different trig ratio. Okay, now tan 38, if we enter that into our calculator, it will give us what the ratio should be of the opposite to the adjacent side in this triangle. So what we're going to do next is we're going to enter in tan 38 into our calculator. Take out your calculator and enter in tan 38. And we get 0.78. So the tangent of 38 degrees is equal to 0.78. So I'm going to replace tangent of 38 with 0.78. And that is equal to A over 6.5. And if you wanted to, if it makes it easier for you, you could actually turn this into a fraction. 0.78 is just 0.78 over 1. Because now this looks really similar to what we did earlier this year with proportional reasoning. Right? We need to now solve this equation for A. What are we doing to A right now? On the right side, what are we doing to it? What math operation happens in a fraction? Division. What's the opposite of division? Multiplication. So to undo division by 6.5, we multiply by 6.5. And we do that on this side as well. Okay? Well, these are going to cancel. And we're going to end up with A equals 6.5 times 7.8. No, not 7.8, sorry. 6.5 times 0.78 divided by 1. 5.07, so I would probably round that to 5.1. And typically what I do with rounding is I round to the same decimal point as whatever's given to me on the other side lengths in the problem, right? So if I look here and I say, okay, all of my, this side is rounded to the nearest tenth, I would round this one to the nearest tenth as well. But if you left it as 5.07, that's fine too. Yeah? All right, let's do one more. And then I'm going to get you guys to try some yourself. But you know what, guys? This is trigonometry. That's pretty much it. We'll learn how to use this in some applications, some real life problems. But if you can do this, if you can use these ratios to find an angle, and you can use these ratios to find a side, you're good. Okay? All right, here's another one. So we're going to start out by labeling our sides. Which angle should we use to label our sides? Firstly, actually, before you do that, you may actually want to look at the question and say, am I being asked here for a side or an angle? What are we being asked to find here? Side. Yeah, we're being asked to find that one. Okay. So which angle should we use to label all of our sides? The 60, because we know that one. Yeah. Okay, well, let's go for it. All right, well, which is the hypotenuse? X. Okay, so that should actually give me a hint right now. I want to find the hypotenuse. Which trig ratio, do I need to eliminate right now if I want the hypotenuse? Tan, because tan doesn't include the hypotenuse. I need to use one of the ones that's going to involve the hypotenuse so I can solve for it. So that's not going to work. Okay? All right. The other sides. Which is the opposite side? Which is the opposite side? Is it the 6.1? Take the angle, go across from it. No, this is the opposite. Okay, so I really highly recommend, in fact, here's what you can do. To find the hypotenuse, go to the right angle, go across from it. To find the opposite side, find the angle you're labeling, go across from it. The adjacent one is the other one. Okay, so we've eliminated tan because we want the hypotenuse. Tan doesn't include the hypotenuse. Okay, we want the hypotenuse. We know 60 degrees. What's the other side that we have that we know? We know the 6.1. What is that called? What's that side called? The adjacent. Okay, so we have the adjacent. We want the hypotenuse. What trig ratio do you think we should use? That involves adjacent and hypotenuse. Yeah, write this at the top. Anytime you're using trig ratios, write that, so, ca, toa at the top, and then they're right there. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? Cosine involves adjacent and hypotenuse. So that's the one we're going to have to use. Okay. Cosine theta equals adjacent over hypotenuse. Okay, let's fill in what we know. Do we know the angle? Yep, what's the angle? 60 degrees. Do we know the adjacent side? Yeah, it's 6.1. Do you know the hypotenuse? Nope, it's x. Okay, good. Where should we go from here? When we were at this stage with this question, what did we do here? What did we do over here? What was our next step? Yeah, we plugged tan 38 into our calculator. Because remember, tan 38 is a value that's stored in the memories of our calculator. So let's do it. Cosine of 60. .5. Oh, wait, I just want 6, not 0.6. Okay, cosine of 60 is 0.5. Yeah. Okay, now if I were to put a denominator in here to make this into a fraction, 0.5 over what? What would the denominator be? Over 1. Okay. So now this one is a little bit different to solve from the last one because the variable is in the denominator. So there's 2 ways that we can go about this. One of them is something that we did earlier in the year with proportional reasoning. What was a workaround that we used when the variable was in the denominator? Yeah. Yeah, you can just flip, you could take the reciprocal of both, right? Reciprocal is when you switch the numerator and denominator. Right? So if like 1 over 2 equals 2 over 4, that's true, because 1/2 equals 2/4, then 2 over 1 has to equal 4 over 2. That's also true. So one thing you can do to solve is you can turn this into a fraction and then go here. So this is like method 1. And I expect some of you will want to do this. So flip, right? 1 over 0.5 equals x over 6.1. And now your variable's in the numerator. Yeah, so now we can just multiply by 6.1. And then these cancel, and that ends up being, when you go 6.1 times 1 divided by 0.5, you get 12.2. Okay, that's one strategy. Method 2 is you can algebraically take steps to get x out of the numerator. And in fact, we did briefly discuss this as well when we did proportional reasoning, but I believe most of you chose to do it the other way. So I'll just review it quickly, but again, choose whichever you think is going to get you the right answer most of the time. Okay? So we don't like having x in the denominator. That's not very easy to deal with. So what we can do is to undo division by x, we can multiply both sides by x. Okay? And then these cancel. So x divided by x is just 1. So what we end up with here is x times 0.5 divided by 1 is just 0.5x. And that's equal to 6.1. And now what we're doing to x is actually multiplying it by 0.5. So to undo that, we would divide it by 0.5. And we have to do that on both sides. And these cancel, and you get the same answer. Okay, so pick whichever strategy is going to work for you. I don't care. But you do need to recognize that if the variable is in the denominator, you at least need to take this step, right? Where you like flip the fractions around, you take the reciprocals of both, so that you can solve it this way. Does that make sense? Okay, so for the rest of class, basically, you guys, in a nutshell, we have covered trigonometry. I know you haven't had much time to practice, but for the rest of class, I would like you to try the questions C and D on page 9. And for homework tonight, I know that this is very jumbled and it's kind of all over the place, but I don't like the way that the workbook lays out trigonometry. I don't like the way that they lay it out, okay? And I tend to introduce it differently than the workbook does. And so what you're gonna find is that the homework is going to be like one question from one page and another question from another page and another question from another page. Okay, so that's what you're going to have to kind of put up with. So the homework is all jumbled up. Okay, you only have to do 4 questions total. but it's from 4 different pages. Okay, so I know that this is brand new, which means that it is very important that you spend some time tonight and tomorrow and over the weekend doing these questions, because starting next week, we are going to be picking up with trigonometry. Okay? Thank you. Excellent work today.